Welcome again to another episode of the Southwest Climate Podcast. This is the end of April edition. This will probably come out, though, in the beginning of May.
April Fools.
April Fools was a while ago.
We were supposed to come back by April Fools.
And that's Mike Crimmins. Mike, how you doing?
I'm doing great, Zach.
How's the sabbatical treating you?
Oh, it's wonderful. It is. All I do is podcast.
We feel fortunate. We can tap into your deep knowledge of the Southwest weather.
I'm living it, man.
And right. I have to congratulate you. This is episode number 45.
I think it is, actually.
Longest running podcast focused on climate in the Southwest. So
somebody's going to count those up and it'll turn out it won't be 45.
I think it's been nearly a month and a half since you and I got together, so it's nice to be back in the same room.
Yeah, it's good to catch up with you. And in March, we were trying to look forward to see what would happen in April, and now we know.
We're going to take a look back at the entire winter season, do a little recap of that, talk about the climatological features of this upcoming sort of fire and brimstone season.
Oh, yeah.
And maybe look forward, although at this point in the year, it's more of a black box than at any other time during the year. So
many fronts.
You'll do your best version of creative commentary.
Try to bait me into making a forecast, as usual.
You're probably as skillful in your predictions as
the
as
problem
the models.
is that these are all recorded, and somebody could actually go back and do a skill score on both of our forecasts.
What do you think you'd turn out?
Oh, it'd be bad. I don't think I'd beat climatology.
So we just pretty much discredited what we're about ready to say. So in other words, like flip a coin.
First time.
You're better off flipping a coin than listening to Mike Crimmins.
Got that on a t-shirt.
No, but we've got some things to say, so we'll try to say it. The winter, for the most part in the southern part of Arizona, it was defined by pretty much a 30-day period. A southern third of Arizona, for the most part, if you look back to the end of October, so November, December, January, February, March, and April, the southern third of Arizona was below average, where the rest of the Southwest basically was above average.
Yeah.
California received some of its wettest conditions on record, rivaling, at least in the snowpack, rivaling the 82, 83 and the 97, 98. But it missed southern Arizona. That's actually quite depressing.
I keep trying to make sense of this because I think if you go back through the podcast, I was kind of glowing. We had a couple months there where I was fairly cheery and happy because of the gray weather and the fairly frequent precip we were seeing, in December and January. I must have become delusional in February because I kept kind of hanging in there. We had that really warm spell in February. We did pick up an event, and this is again southern Arizona, later in February, and then kind of March turned into summer, and then we've just been kind of off to the races ever since. It really is been an active winter, much more active from a weather pattern standpoint than the kinds of weather patterns we saw the previous winter. We actually saw a lot more blocking ridges and quiescent but warm periods there. We've actually seen quite a bit of weather. It's just that the southern part of Arizona has not gotten the precip out of them. The northern part of the state has continued to pick up very active weather pattern precip all the way along, even up until just even the last couple of days.
Right. It's really a tale of two parts of the state.
Exactly.
I mean, if you look at Tucson, for example, since October 1, we've measured about 3 1/3 inches. That's about 2 inches below average. Most of that came within a 30-day period between mid-December and mid-January, which is quite odd.
The October-November period was dry. Only a handful of events. October was very dry, very, very warm. November was pretty quiet, 1 or 2 events, and we were below average, or from the water year October 1st through the beginning of December, we were not hanging in there. And then it wasn't until December and January we really picked up speed quite a bit, and I actually caught up to the water year total, just about hit average by the middle of January. And then since then, the southern part of the state has gotten left out of the precip, and we've really trailed behind. So the water year to date, we're now looking at we're an inch and a half below average now, which is pretty sizable deficit even after having that pretty good midwinter rally with precip. The slowdown in February and March, those are 2 months that we should still continue to see precip accumulate in southern Arizona, at least climatologically speaking. We didn't get it.
At least at the Tucson International Airport, March only had one event. And I don't think that was experienced area-wide.
No, and the events that did actually put down, a trace to some drops at the airport were these really quick-moving trailing cold fronts. We've had a lot of them come through, and those were the last couple of ones that actually had this one tiny band of showers that literally you could watch it move across on radar. And if you were underneath it and you got some out of it, that was your precip for that event. The break point across the state now climatologically for who's above average versus below average is right about Phoenix.
Yep.
And so north of Phoenix, and it's really going to be elevation at that point where you go up in elevation, you really did start to see some of that precip pick up. But it's also interesting if you go off to the far western deserts like southern Mojave County and even La Paz County, they've done quite well. Again, that's a dry part of the state, but they've actually had above average precip for the winter.
Yeah, and I believe those were in part fueled by a couple atmospheric rivers that were sort of moving in that direction from southwest to northeast.
There's these low elevation stations out towards the Colorado River that have gotten precip in the last couple of events where we haven't gotten it. So it's not just an elevational gradient, but there was events in late February and even again in April where the far western deserts got precip. And again, it was more proximity of the storm track being north of Phoenix, anywhere sort of north of it, both west and to the east, you had a better chance of seeing some of that precip with the storm track that continues.
So another interesting feature that I've seen in sort of the southern part of Arizona, which is the precipitation events have been pretty weak. It's not that we've received fewer storms.
That's right.
We've received right around the average number of rainy days, but the intensity during those days have been below average.
Yeah, just to your point, we've had 28 rain days in Tucson, and for the entire October through end of May period, we normally see about 26. So we're actually above average on the number of times it rained, but as you just said, is that the amount of rain coming in those events is actually below average. So it's kind of an interesting juxtaposition of those two metrics.
In Flagstaff, it's running at 2 or 3 inches above average. They tend to get on average about 13 inches of rain, and right now we're at close to 16.
And they've gotten almost 100 inches of snow, which is a little over 110% of their average wintertime snow.
So yeah, two parts of Arizona, southern part dry, northern part wet. New Mexico has fared for the most part above average since the water year began. So, again, we've been left out here.
Yeah, the epicenter for the short-term drought conditions returning is really Tucson, and it kind of rings out from that to Cochise County and Pima County and a little bit of Pinal. But yeah, like you said, New Mexico, not too shabby. Far sort of southeast part of the state has had a fairly dry time of it, but much of the rest of New Mexico has gotten fairly frequent, kind of normal-ish precip from October till now.
So another interesting feature that I think we should talk about for the winter, particularly the recent months, has been the heat. March came in at the warmest March on record.
For Tucson, right?
For Tucson. Mm-hmm. That heat has been regional. It's been above average across the West. This I found astonishing. March actually had its average high temperatures 9 degrees Fahrenheit above average.
That's a lot. That's not edging out an old record.
Obviously, there's some relationship here between the dry conditions. We weren't getting storms in.
Right.
Typically, those storms would come in. They'd come in from the northwest, bring cool conditions. We didn't see that, and consequently, it's not surprising that it's been warmer than average. But 9 degrees Fahrenheit is
it's impressive. And how do you get to 9 degrees? It's not 2 or 3 just epic record-shattering days, balanced out by a bunch of sort of near average days. It was a run. It was a 2-week run of either record-breaking temps or near record-breaking temps to get you to that particular level.
And that was in mid-March. That was between, I think, the 8th and the 20th.
Typically when you'd see that, you just expect to see a very strong northward displaced ridge. So a ridge of high pressure system, probably even anchored above us.
It's bringing in warmer air from
right. So
the south.
You're in that sort of southwest flow.
It's doing two things, right? It's bringing in warmer air, but it's also
high
deflecting.
Pressure. Yeah, so it's the deflection, so you're not getting the weather systems and the precipitation part of it and the clouds. It's also, potentially the high pressure with the subsidence and increasing the surface temperatures, sort of the atmospheric temperature profile, and then just the advection of warm air into it. But it wasn't terribly striking. We just had a bunch of kind of strange, very shallow ridges park over us and kind of move quickly through there under some really sort of strong zonal flow. So it was surprising to go back and look at the weather maps and say, that's what gave us that. But it certainly did. A couple of days where there was a high pressure system sort of directly overhead. A lot of days where we were just under really fast westerly flow, but in the very warm southern part, just south of the jet stream.
So the jet stream was more north. And
absolutely. It's just
because the Pacific Northwest and northern parts of California and Oregon and, even into the interior received quite a bit of precipitation.
The jet was north of us, and on that very fast jet was pummeling Northern California, and we were in the, just sort of the warm, dry air mass south of that particular jet stream. And it was just enough to be able to be very persistent and very, very warm, giving us those record high temperatures.
At least if you were to think about what the fire impacts might be, this sort of doesn't bode well.
Foreboding.
It's foreboding.
You don't want all of that effort in putting down precip in December and January, and maybe a little bit in February, to just get kind of eaten up and spit out in March. And I think we certainly had a lot of that happen in southern Arizona with the temps and then the lack of precipitation. I do think that it has exacerbated fire danger. I mean, it certainly dried stuff out in the short term. We did see, if you look at some of the greenness metrics from remote sensing, we saw all that nice precip come down in the midwinter and then being followed by that warm up in February and again in March. We had a lot of green up in vegetation, really pushed, I think, probably in a lot of respects, an early sort of spring signal, depending on the kind of vegetation you're talking about. Subsequently, especially with grasses and annuals, that stuff has already senesced and dried out and gone back to its spring senescent state, which means it's ready to burn now, which I think is clearly why we're seeing real concern with fire risk across the state and active fires.
The decent monsoon probably doesn't help that, right? Because it would have laid down a solid foundation for which there'd be a little bit more finer fuels.
We're dancing around the actual active fire of the Sawmill fire in southern Arizona, 30, 40 miles south of where we're sitting right now. And that particular area did see a really wet, productive monsoon season. All that grass and growth has led to really good fine fuel loadings, and now it's ready to go, and it's definitely going.
So before moving on to fire, I do want to just finish talking about the retrospective look at the winter. Now, we did have sort of a weak La Nina. Mm-hmm. And I'm wondering if you think that there is any sort of signal within the pattern here in the West related to that La Nina. I mean, it was a weak La Nina, so one wouldn't necessarily think that we would see it, but we did have some superlatives with precipitation in California, which quite frankly go against what we would have otherwise thought with a La Nina.
I know. And, it's interesting now that, for southern Arizona, we might end up falling right back into our correlation for, we kind of said, it's going to be a dry winter. And, I'm glad we're trying to be more nuanced in our sort of exploration and descriptions of the winters now, because October through March, which is what we would have done in the past, October through March total precipitation, and correlated that with the La Nina or an El Nino with an ENSO index. This is going to be one of those dots that's going to fall below the average.
Right.
The point is that we did have precip in there. It came in sort of a complex manner. The February-March period dried out. Did that have anything to do with La Nina? I don't know.
But wouldn't you have also expected it to be slightly dry or tilting dry in southern New Mexico as well? And it didn't.
It would have, and it didn't. I know.
I mean, I think
it's a little more happenstance.
You have to look at more of a sort of spatial coherence.
Yeah, I agree.
Think about its relationship to El Nino. I mean,
I completely agree with you.
I mean, there's this.
Thank you for backing me out of that corner.
A third of Arizona. I mean, it is odd that Arizona and not New Mexico.
Yeah, it's a tiny little bullseye around the 3 counties in southern Arizona. So did La Nina cause this? I don't think so. I think it was just the approach of a lot of these storms was just not favorable for southern Arizona. And it was favorable for everybody else as far as the access to the moisture and, sort of the timing of those events as they sort of came through.
What about the chatter that has been about the atmospheric rivers and the frequency and and the intensity of those.
There has been a lot of chatter about it, and I think we talked about it in a previous podcast. You kind of brought up some of the statistics that this appears to be a year where the frequency is much higher. I think that some of the things that were at play were not, well, they aren't completely understood for sure, but Madden-Julian oscillation was fairly active at certain parts of the winter, and I think is going to be, and we know is a culprit. Weak La Nina events and neutral ENSO is favorable for these Madden-Julian oscillations, and I do believe it's also favorable for these atmospheric river type situations as well, because you have some dynamics to work with within the easterlies to be able to sort of move some of these wave systems across. And also in the far western Pacific, there's a tons of moisture to deal with, which these really long fetches, atmospheric rivers were able to sort of tap into. And it was just over like the last week too. I was reading a couple different blogs, but there's this amazing wall of water that came in across California again that had its origination all the way back in the Philippines. It was, and you could look at the water vapor imagery, and it was like 3,000 miles long. It was really wide too. So it didn't have the hallmarks of an atmospheric river. It just had this giant subtropical plume that extended all the way across the Pacific Ocean. So I think there's still a lot of moving parts we don't really understand. And a lot of the chatter for this winter too is a lot of interest in what's been going on in the Arctic and its interactions with both Madden-Julian oscillation and sudden stratospheric warming events, whether they're occurring more frequently or less frequently than we'd expect to see, and using those as forecast tools, and then how that has been interacting with the weather pattern across the entire globe. No real definitive saying this was the culprit. It seems to be, again, like kind of a mishmash of a lot of different really active and interesting weather patterns continuing, and they continue to this day. And it looks like in the next 2 weeks, the weather pattern continues. I think largely southern Arizona is probably out of play from here on out. I just think we're done. But it does look like, and you can see this in the 2-week forecast, the upper basin states are still under an above average precip forecast even for the next 2 weeks. It's not quite Miracle May kind of levels, but it's worth watching. I don't see that as exactly what's going to be happening, but it's still kind of interesting to see that we might continue to pick up precip in the upper basin. It's not going to solve the issue of the cratering snowpack, but it's still
there's still quite a bit of snowpack around the west. The Sierras are way above average right now. Snowpacks in the upper Colorado River Basin are, some of the lower elevations are near below average, near zero, and probably the ones at higher elevations are above average. And that probably reflects the warm temperatures. It's still been above below freezing at higher elevation, so it hasn't been able to eat through the snow as much. But the lower elevations ones are getting melted out pretty quickly.
Yeah.
So now we're transitioning into the May and June season, the pre-monsoon season, which maybe we should talk a little bit about the climatological features. So I was trying to think about what's interesting about this upcoming 2 months. For me, it's characterized by pretty fierce wind.
Yeah.
Temperature starts increasing, it's been increasing, but it ramps up to its peak and close to the end of June before the monsoon season comes in. Fires become the main impact. It's also the point in time, I think, when we, at least from a forecast perspective, we know very, very little about what the future seasonal climate's going to be like, particularly the monsoon, because that's a hard thing to forecast. But even also looking forward into, what ENSO is going to do, what El Nino and La Nina are going to do. That's
a really good point. I haven't really thought of it that way. You're completely sure of how miserable the next 6 to 8 weeks will be, but at the same time, you have complete uncertainty about what's going to follow. Right? You're right. It's kind of a weird.
We know it's going to be hot and dry.
You know that it will break in sometime in July, but you don't have any idea how it's going to play out. The El Nino forecast, this is exactly the point in time where you're getting some insight about what's going to potentially be at play for the following winter, just based on our El Nino forecast, or La Nina.
But the winds. So, this is the time, the fire danger is the highest, in part because this is when there's very windy conditions. We're having another red flag warning today.
We've had a run of them, yeah.
So thinking about the climatological feature here.
Yeah, yes.
The wind is a prominent element of, May and June.
Right.
So let's talk a little bit about why that's the case.
The wind is a response to a gradient of atmospheric pressure. And the gradient of atmospheric pressure is largely because it's warm south of here in response to the sun angle increasing. And, that's actually what's going to bring us our monsoon ridge, right? So that monsoon ridge is starting to, bubble and broil south of here, and we'll start to try to advance north. There's also, though, winter's still happening north of us, right? If you kind of now visually cut the atmosphere as a cross-section and you think about with colder air, the atmosphere is compressed. It takes up less space because it's colder. And as you go south, it's warmer, so it takes up more space. So the atmosphere is actually thicker south of us. So it's just like a topographic map. And so the atmosphere with the same amount of mass is actually taking up more space south of here, and it's less north of here, right? Okay, so just like we were just saying, there's a slope that topographically, that higher pressure or that thicker atmosphere wants to flow north towards the colder atmosphere, which would be upper level, low pressure system, and the jet stream responds in concert. That battle between sort of the warm air to the south and the cold air to the north is what's going to drive both the upper level winds and the surface winds. And the steeper that gradient is going to drive then faster winds that will be both at the upper levels and the lower levels. And so this time of year, we often will have very cold air trying to kind of plow south out of those low pressure systems, and it'll collide with this warm air that's not too far south of us here. And so when we get those really sharp gradients, we end up having these really, really strong winds. So
does that sort of smooth itself out come mid-June, or when do the fire, like the red flag, the really intense days of wind end?
They cease as the monsoon ridge pushes into the area. And so we can actually have these really, really strong winds right to the last week of June, and we've seen that in past. And some of the really busy fire seasons, you'll still see these very dry, windy, low-pressure systems still kind of barreling out of the northwest and across the southwest. They do nothing but create wind, no clouds, no nothing, just create wind. And it's not until that monsoon ridge can actually muscle its way in and ridge across the entire southwest, where that storm track is far south and the jet is much further north, that you'll continue to see these red flag type events. And it's as soon as you get in the monsoon, they don't come back. You don't see this pattern return until the storm track starts to move south again in November.
So red flag actually has a technical definition.
It does.
Do you know what it is?
It's just like a test, right? It's like
well, I have it in front of me.
It's a wind speed and a relative humidity, right?
Yeah, it's a wind speed
threshold.
Do you know how high the wind speed has to be?
34.9 knots.
Wow, that's actually
really?
Pretty close if you would have said miles per hour. No.
Oh.
The definition is sustained winds for 3 or more hours of sustained winds of 20 miles an hour or greater, or gusting up to 35 miles an hour.
Nice. Okay.
Yeah. And the relative humidity is less than 15%. So this is peak fire season in the Southwest is July.
Is it really?
June and July, yeah. It actually evolves in Arizona. It's ramping up from April, May, June, and then it peaks in July.
And so that's total acres?
It's actually the frequency.
Frequency. Yeah. Okay, that's interesting. Yeah. So I suppose you're right. So then by July,
when the monsoon comes, obviously
exactly, it's the lightning.
So right now in the Southwest, I believe we've had one large fire that's ongoing, the Sawmill Fire, and that's pretty much the only large scale fire that's happened in the Southwest.
Yeah, that's a big fire, largely in grasslands too. I don't believe we've had a large grassland fire in several years of this magnitude. The
total acres burned in Arizona on average is about 200,000. Since 1990. The median, however, it's a skewed distribution. The median is close to 100,000. We've had seasons that have burned. Well, the highest season was close to a million acres. That was in 2011. Yeah. Last year we had 158,000. The year before that, 200,000. That's in Arizona. New Mexico, which I was actually surprised to read this, actually experiences a higher number of fires and more acres burned on average and in the median. Huh. Yeah, so close to 269,000 acres burn on average in New Mexico, with the median being 188. 183,000. And its epic fire season was again in 2011. So that kept fire managers super busy that year. I remember that year. And another interesting trivia is that about half the fires are caused by humans and about half are caused by lightning, with the lightning probably starting later on in June, not so much in May. Anything interesting or worth talking about with the sawmill fire?
The surprise of how quickly that fire moved, I think, is what is pretty remarkable. The forward rate of spread, both the wind and the weather, and also the fuels that it was burning in, which was a lot of grasses that had really filled in post-monsoon season of last year.
What are the impacts of that, like with the grasslands, in subsequent seasons or subsequent years? I mean, did the grasses grow back differently?
Some grasses really like fire, others don't. Fire overall for grasses can be good. It will be interesting to see how these places come back. And fire is a management tool for grasslands. It's just that you want to have some control over it. And this was not one of those situations.
It's really hard to control when you got 35-mile-an-hour gusts.
Exactly. It got a type 1 incident management team, which is the top type of team with the most resources.
We'll be paying close attention to the fires as we progress along here.
Yeah, the hope May is a little bit quieter, but I don't know. The ingredients
if
are there.
climatology is
exactly.
is any indication. If our best guess is the historical climate, then we can expect more frequent fires. But that's not to say that they'll be bigger.
That's right. I mean, we can expect maybe the activity will continue to pick up, but hopefully we won't have this kind of out of control ones. I guess they're all kind of out of control, though.
Transitioning here now to the black box of the future. There's indications that El Nino may actually be on the horizon. It is the best estimate right now, even if our ability to forecast future conditions is at a minimum. There's still indications that we may expect El Nino to return. From what I've seen, there's warm water in the subsurface of the ocean, which is sort of fueling that forecast. It's
interesting, as I was reading a lot of the forecast discussions and looking at a lot of the models for El Nino for the next couple of months, and watching the IRI forecast discussion that came out and the ENSO blog, that I thought it was a little bit more like kind of slam dunky, maybe just a couple weeks ago, where the models really were starting to pick up on some signals and really lean towards an El Nino. And it has really kind of gone in the tank over the last 4 weeks in particular. There's a lot of consternation now about whether there's enough there to actually put an El Nino in motion and sustain an El Nino. And the dynamical models believe that there is, but are maybe bullish. And the statistical models are yawning at what they're seeing right now. And the other interesting factoid that you probably heard too is that there's only been one instance of a back-to-back-to-back El Nino, La Nina, El Nino since 1950. And that's part of why the statistical models are yawning, because there's just not a much precedent of this situation occurring.
When I read that, it made me think, if that comes to play, does it undermine or throw into question sort of the dynamics of what we know about, given that we've had sort of the opposite signal recently, and the position of the jet stream has been slightly north of what we would have expected last year, and that the system itself is acting in ways that we haven't seen before. I mean, how do we sort this all out?
To me, it's just humbling, the humility that we need to probably have with where we're at as far as seasonal forecasting and our understanding. And so I think is increasing. I think we're also coming to terms with the fact that we have a very, very short period of record of events that we're trying to make analog forecasts out of, or even just understand dynamics. And probably equally important is that the climate system is changing out from underneath us. So the analogs may not be as helpful as they are in the past, because if you look across there, the climate change signal across the oceans is just, you can't ignore it. And it's a huge part of this, I think, non-stationarity.
When we're looking at the seasonal forecast, the dynamical models seem to be a little bit more bullish on warmer sea surface temperatures than the statistical models. But if, which ones do we pay more attention to, particularly given the fact that the climate system is changing under our feet, like how representative are those statistical representations?
I think it's fair, and I think it completely depends on the type of model and what the model is sort of cueing in on. The statistical models are probably conservative, and the dynamical models have this kind of momentary bias issue where whatever they see when they're being sort of initialized, they'll kind of carry forward, right? Which is what we've seen in the past. Is I think that they were queuing up some subsurface warm water in these Kelvin waves they're expecting to sort of move across. But if you look at the subsurface temperature profile across the Pacific right now, it's not terribly impressive. And there's actually some cooling water that will continue to upwell in the Eastern Pacific. And so the timing isn't great. You want to start to now see these releases and movements of water across the West Pacific and get some reinforcing convection to try to start to drive the system more towards El Nino. It does not mean that it couldn't happen later in the season, but it's just like the pieces and parts that are together in sort of this April-May period. We are still in that predictability barrier zone. There's just too much noise in the system, I think, to sort out one way from the other, which is why I think you see some of the much more conservative forecasts being a coin flip between El Nino and neutral at this point. Clarity should emerge by the time we get to June.
This uncertainty is sort of reflected in the IRI and the Climate Prediction Center sort of joint forecast.
Absolutely.
If you look at, they release El Nino, La Nina, ENSO forecasts twice a month in the early parts of the month and then in the middle month. In the early parts of the month, it's the statistical dynamical models, but also sort of the expert
getting
judgment.
In and tweaking it, yeah. Uh-huh.
Whereas the forecasts that are issued in the mid-month do not have the expert judgment in it. Just looking at the most recent two forecasts, the early April ENSO forecast, the probabilities for El Nino crest at 50% in the fall and late summer and the fall. Whereas, fast forward 2 weeks to the mid-April forecast, and those El Nino probabilities crest at 70%. So I think that, the forecasters are like, the models aren't, they're over-interpreting perhaps, or they're not picking up on the fact that we historically haven't been as successful at this time of year at forecasting. So they're a little bit more cautious. I think there is something, though, in here, even if we don't know if it's a El Nino or a neutral, it's exceedingly low that it would be another La Nina.
Yeah, I think we're safe there on that part of it. The thing that I just refuse to want to get too interested and excited about was, and I think this was a detriment to really understanding the last El Nino event, the subtle differences between when we talk about an El Nino actually happening, of whether or not it's a Central Pacific El Nino or it's an Eastern Pacific El Nino. And I think you've even brought it up last summer or last winter when we were trying to diagnose this. This is coming out in literature a little bit more. And now I'm trying to look at what some of the forecasts are actually saying about if this thing does turn into an El Nino, it really has more of a Central Pacific look to it, not an Eastern Pacific one like the 97-98 event. The interesting thing is that coastal El Nino that was hammering South America would have been more what we would have been calling an Eastern Pacific one. But as this one potentially evolves and moves forward, it takes on a much more Central Pacific look to it. Why do we care? It seems to be that actually matters with the subsequent jet stream. Could even be part of the reason why we didn't see exactly the kind of impacts that we had expected to see last winter.
It makes sense where the position of the greatest convection is.
Absolutely.
Right?
If
the atmosphere is sort of tied together, it sort of acts as a fluid.
Yep.
Where that position of convection is occurring should ultimately have an influence on downstream issues.
Yep.
When people are coming up with the impact model, so like the precipitation forecast, not the El Nino or not the ENSO forecast, but the impact forecast, are they looking at the sea surface temperatures within what's traditionally called the 3.4 region? Are they just averaging over this sort of box within the Pacific Ocean, or are they taking more into consideration the sort of spatial pattern? Do you know?
Some of the statistical methods won't. Some will, some won't, depending on how sophisticated they are. The dynamical models, though, should have the heating anomalies and the geography and the spatiality of them sorted out to produce the right impacts. And I haven't seen the paper yet, but I'm waiting for it. is to try to have that really good deconstruction of what happened. I do have one in my bag I haven't read yet that I'll take a look at, and I'll have you take a look at too. Maybe we can talk about it a little bit more, see if we can learn something from last winter.
It's specifically focused on last winter.
It's the CPC and IRI and many other scientists doing the diagnostic of the 2015-2016 El Nino, and
that'll be interesting.
A BAMS article that's in press right now.
We could talk about that.
Okay.
I'm going to refrain from moving this discussion to talk about the monsoon. What do we have to say about
not much?
What's going to happen in the monsoon?
I just hope it rains somewhere. It will. You know what? I'll put money on that. It'll rain somewhere.
We're going to get you on the record for you. We've got to do our prediction again.
Do we do that? We actually do that.
I think
right?
I won.
I think you probably did too. Yeah, I didn't ever pay you for it, did I?
Did
we ever pay you for the?
You still owe me. You still owe me a couple beers. Well, give us the parting word, Mike. I'm putting you on the spot here.
That is really freaking me out.
We got to get you some coffee.
Apparently so. Yeah. So I'm already thinking about the monsoon now.
All right. Well, I actually can't wait for the monsoon. The worst time in the Southwest. I have mixed feelings about this time, but the worst time.
We can hang in there together. We'll be our own support network.
Is May and June.
I'm going to tell everybody though, you're leaving for most of June anyway, so I'm not sure what you're whining about.
And what are you talking about? You're on sabbatical.
That's right. I'll just be hiding in.
You basically hang out in your house and
I'll
sip
be hiding
lemonade
under a
during
blanket.
the day, and
that's
then,
right.
You know.
Yeah, it's exactly sip lemonade. That's
You're
exactly what I've been doing.
Maybe I'll read this BAMS
Maybe
article.
I'll be. Yeah, I was
tough
printing
life,
it out.
Mike. Tough life. All right. No, thanks for that, Mike. I learned something there.
Okay, good.
All right, so we will come back in another month and update you all on recent weather and climate conditions here in the glorious desert of Arizona and New Mexico, and thinking more broadly as well. Cheers.
See you, Zach.
The Southwest Climate Podcast is a production of CLIMAS, which is part of NOAA's Regional Integrated Science and Assessment Program and is housed at the University of Arizona Institute of the Environment. Mike Crimmins is a principal investigator with CLIMAS, a professor of soil, water, and environmental science in the College of Agriculture and Life Sciences, and climate extension specialist with the University of Arizona Cooperative Extension. Zack Guido is a research scientist with the Institute of the Environment and UA program manager of the International Research and Applications Program. The podcast is edited and produced by Ben McMahan, research, outreach, and assessment specialist with CLIMAS.
Should we begin without Ben?
Is he really? Did he really start recording and just leave? That's hilarious.
We even got a little bit of the Arctic in.
We did.
We always talk about the tropics.
We do.
You know?
We do.
Should we talk about Australia next time?
Let's try it.